Hello everybody, welcome back to the channel. So today we're going to learn how to solve for x using exponents. So the primary reason in using exponents in solving for x, we're trying to achieve a common base so we can deduce from the laws of exponents that when you have the same base, you can actually equate the exponents and find your x. So in this problem, we have a base of 2 to exponent x plus 2 plus a base of 2 to exponent x equals to a base of 20, right? So the first thing I always want to do is to break the exponent terms and simplify the values to the smallest pair factors, right? So in this regard, I have x plus 2 as my exponent terms, 2 exponent terms. So I'm going to first break that into 2 exponent x times 2 to exponent 2. Then I'm going to write this as it is, plus 2x equals to 20, right? So the second step is to break this into the smallest pair factor, right? And we know that 20 equals to 5 times 4, right? Whereby 4 can also be simplified as 5 times 2 to exponent 2, right? So I'm going to write, this is multiplication, so this I'm just using dot here when I'm working with exponents. So this I'm going to take it to this side because I've simplified into this smallest base factors, right? So we're going to have 2 to exponent x times 2 to exponent 2 plus 2x equals to 5 times 2 to exponent 2, right? Then from here, I'm going to take this common factors and I'm going to take them out and simplify this side. So we have 2 exponent x into this value, 2x, sorry, is 2 to exponent 2 plus 1, because I took this 2x to the outside, as you can see here, so I'm going to be left with 1. Then equals to 5 times 2 to exponent 2, right? Then from here, I'm going to add these values. So 2 to exponent 2, we know this is 4, plus 1, it's 5. So this is 2x times 5 equals to 5 times 2 to exponent 2, right? Then from here, we're going to divide this 5 or cancel 5 both sides, right? So to do that, we have to divide by 5 both sides. Divide by 5 both sides. What you do on the left, you must actually do on the right. And these values, they cancel each other. And then we are left with 2 to exponent x equals to 2 to exponent 2. Then from this, we know that when we have the same base, we can actually equate the exponent as bases. So this is going to be x. It is going to be x equals to 2 because the bases are the same. The bases are 2, they are the same. Then we equate the exponent as bases. Then our answer is x equals to 2. So with the second problem, we have a base of 9 and a base of 2 to exponent x minus 1 and a base of 2 and a base of 3 to exponent x. So in this problem, we're going to simplify this value of 9 because it can be simplified to the smallest base exponent, and also this base of 2 to exponent x minus 1. We're going to simplify this exponent terms x minus 1. In doing so, I'm going to write this here Here it's 9 equals to 3 times 3, right? And can also be simplified again to 3 to exponent 2. And then in terms of 2 to exponent x minus 1, we have 2 to exponent x times 2 to exponent negative 1, right? Negative 1. So I'm going to take these values, the simplified version, and I'm going to plug them into the equation, right? So in the first term, 9 can be simplified to 3 to exponent 2, and then 2 exponent x minus 1 can be written as 2x times 2 negative 1, right? Then all of this equals to 2 times 3 exponent x, right? So from here, we're going to take all these values to one side, because I can see I have base of 3 and a base of 2 which are common. So I'm going to take these values, these terms or these values to one side, and then simplify the numerator and the denominator to all being a numerator, and simplify the exponents, right? I hope you together. So I'm going to start by dividing by this value, or you can also divide this term. It's up to you. So in my regard, I'll just divide this one, 2 times 3 to exponent x. I'm going to divide both sides by same value, so 2 times 3x, right? And then after doing that, obviously these ones, they cancel out, right? So I have accomplished moving this term to this side, right? So after dividing both by one value, we're going to have obviously a 1. So this side we left with 1, because when you divide same value, you get a 1. So in this regard, we left with the same value, 3 to exponent 2 times 2x times 2 minus 1 divide 2 times 3x, right? Then from here, we're going to take this value to the numerator, right? And to achieve that, I'm just going to write some note. Suppose we have 1 over 2, and we're trying to take this 2 to the numerator, right? Then we're going to have 2 to exponent negative 1. And this is because when you have 1 over 2, right? 1 over 2, you have an imaginary 1 here. And then when you have an imaginary 1 here, when this 1, which is positive 1, obviously, when this positive 1 goes to the numerator, it changes its sign. So it becomes 2 to negative 1, right? So with also this 3x, 3 to exponent x, we have 3x, right? Let me just do this. We have 1 over 3x, not 3x. We have 1 over 3x, right? Then this is automatically positive. When there's no sign given, it's positive. And then when we take this 1 over 3x and we're taking this 3 over exponent positive x, we're taking it to the numerator. It changes sign, so it's going to be 3 negative x, right? Then we're going to use these values we got and we're going to plug them into the numerator. Times 2 to exponent x times 2 negative 1, right? Then I'm taking this denominator to the numerator, right? So we have an imaginary positive 1 and we have also, like this side, positive x on this side. This is positive 1. So when they go to the numerator, they changes their sign. So that 2 becomes 2 minus 1, and the 3x becomes 3 negative x, right? Then all of this equals to 1, right? Then from here, we're going to simplify. We're going to simplify by using the law of exponent that says when we have the same base, we can actually add the exponents, right? So we're going to do that now. So I'm going to add the like terms and the like base terms, right? I'm going to add their exponents. So in this regard, we have 3, right, to exponent 2. We're going to add it with its like base term. So the base this side is 3 to exponent 2, and then the base this side is 3 to exponent negative x. So we're going to add their exponents. So this is going to be plus negative x, and then multiply by 2, right? And then we're going to add their exponents, right? So that is x plus negative 1, this one, plus this one, negative 1. All of this equals to this one, 1, right? Then from here, we're going to add up the exponents. So it's 3, 2 plus minus x is going to be 2 minus x, right? 2 minus x times, we're going to add up this exponent, so we have 2x minus 1 and minus 1, right? All of this equals to 1. Then the next step, we're going to add up this negative 1 too, because they have the same sign, they're going to be added. So it's going to be 2 minus x times 2x minus 2. All of this equals to 1, right? Then the next step from here, we're going to, because these are more like similar, they are similar, so I'm going to try and put this term the same as this one. So I'm going to try and put x first and then the value next with this term, right? And to do that, this is what I'm going to do. We have 3, and then I'm going to start with x. So it's going to be negative into x minus, because when you multiply negative times negative, you get a positive, and here there is a positive sign. When a value is not assigned any sign, it is positive. So there's a positive sign here. So negative times negative is positive. So it's going to be 2, positive 2 here, right? Then I'm going to write this as it is, multiplied by 2x minus 2 equals to 1, right? Since I'm trying to take this up, but it's heavy, so let me just try and put a line here. Oh, there's the line, and it went up. So from here, let me just take it down. So from here, we're going to take this to the numerator, this value here. And the reason I'm taking it to the numerator, I can see that this have now same exponent, and then the only problem is this sign, this negative. So I'm going to take it to the numerator. So we're going to have 2x minus 2, right? And I'm going to divide it by 3x minus 2, because now this becomes positive. This sign then becomes positive when it goes to the numerator, right? Then all of this equals to 1. Then from here, we're going to simplify this whole term. We're going to simplify it, and to do that, since we know that it has the same exponent, we can actually put it as a whole exponent of 2 over 3, because it's more like 2 squared over 2 squared, right? All this can be put as 2 over 2 squared. So we're going to do the same principle here, right? So in writing that, we're going to have 2 over 3 brackets x minus 2, right? And all of this equals to 1. And we're going to further use the law of exponent with this side, that anything to exponent 0 is 1. So using that principle, we're going to have this side, we're trying to have the same base. So we're going to put the base of this side to the other side by applying the law of exponent, that when you have a value to exponent 0, that value, no matter what it is, it's 0. It's 1, sorry, it's 1. So in this regard, we're going to have 2 over 3 exponent 0 equals to 2, this one as it is, 2 over 3 x minus 2, right? So from here, we can see that these values have the same base, right? Since we know that this one equals to 0, equals to 1, sorry, equals to 1. So they have the same base. Now, since they have the same base, we can equate the exponents. So we're going to have x minus 2 equals to 0, right? And then you're going to take this negative 2 to the other side, and when you do that, it changes the sign. Then from there, you're going to have x equals to 2, and this is your answer.